Alright, so once you've collected your data and you've run your logistic regression analysis and you've obtained your model, you cannot just use the model immediately. Like linear regression, you need to check whether this logistic regression model is good enough or not. And there are two things that you need to do. The first one is to check the beta values of the IV. So you recall, beta values essentially represent the strength of the relationship between the IV over the DV. But because the data you got for your analysis was a sample, you need to check to see whether the beta values or the beta weights were obtained in error or not. So like linear regression, check their p-values. Look through all the beta values and the associated p-values to see which are statistically significant and which are not. So you discard those that are statistically non-significant. For those that are statistically significant, then you go ahead and examine the size of the beta values to see which are more influential and to see which are less influential. Now the thing here is that different from linear regression, the beta values are from 0 to infinity, so unlike linear regression. And you interpret the beta values differently. The values are interpreted as odds, chances of something happening. So the larger the beta value, it means that the larger the influence of the IV over the DV outcome. So let me repeat that. The larger value means there's an increasing chance that the IV is more influential over the DV's outcome. So in this case, we are predicting DV to be 1. Now, if the values are less than 1, it means that there's a decreasing chance that the IV is influential over the DV's outcome. So let's take a look at a couple of examples. So let's say you want to predict whether someone will have a heart attack or not given his or her smoking habits. So heart attack would be the dependent variable, and it can be either yes or no. But you recall we need to reframe our logistic regression question such that heart attack is equals to yes. That means the dependent variable is 1. Heart attack equals to yes. And the independent variable would be whether the person smokes. So what you do is you collect the data between smoking habits and whether a person has a heart attack or not. Run this through a logistic regression analysis, and then you get your regression model. So the regression model will give you the IVs and their associated beta value. So in this case, let's say your IV's beta value, that means whether a person who smokes or not, the beta value is 3. Then what this means here is that a person who smokes is 3 times more likely to get a heart attack. Now if the IV's beta value is 0.5, then what this means is that a person who smokes decreases the chance of heart attack by half because it's 0.5. Of course, this is just a fictitious example. Now, please do not take up smoking. Okay, let's look at a more involved example. Let's say you are a university administrator and you want to find out what are the factors that would influence whether a student will stay in his or her degree program or not. So in other words, you're interested about student retention, and as a university, you want to help students stay in their degree program and not drop out. So let's say you collect a bunch of data. The dependent variable will be whether the student stays in the program. So you have yes, that is represented by 1, no, that's represented by 0. And then you have a bunch of independent variables, such as the number of years the student stays in the program, the student's GPA, and whether the student was working or not. So this is some example data which is fictitious. So for example, in the first row, the student stays in the program for 4 years, his GPA is 5, and he's not working. And the end result is the student stayed in the program. In the second row, the student was in the program for 1 year, GPA was 1.4, and the student was working. And the result is that the student did not stay in the program, so that is a 0. So you have all this data, you give it to your statistical software to produce a logistic regression model. Now, among other things, the logistic regression model will be a table of values, right? And this table will contain all the independent variables, their beta values, which represents the odds, and then the p-values. Okay, whether they were statistically significant or not. So shown in this table, okay, you have the 3 independent variables, the associated beta values, and all of them were statistically significant. That means all of them can be admitted for further analysis, which is to compare the relative influence. So what this table tells us is that the longer the student stays in his or her degree program, the odds of staying is 2.9. And as the student's GPA rises, the odds of staying is 3.6. And finally, if the student happens to be working, the odds of staying is 0.9. So there's a decrease in likelihood of staying. Now, if you were to look at all the beta values, the most influential is GPA. Okay, so GPA scores would influence the fact that the student stays in the program. This is followed by how long the student is in the program, and then finally whether the student is working or not. So if you're a university administrator, you would focus on these factors and try to keep students in their programs by first, flagging out perhaps students with low GPA scores and counsel them, or how long the student stays. So if the student stays longer, you're perhaps more confident that the student will remain in their degree program. And for those students who are working, you might also want to flag them for counseling to make sure that they're able to manage their time better.